if you move from the left hand side, this is called 0.99999, right?
Yeah.
So if you move from the right hand side, this is called RHL, right hand limit. All right. If you move from
Yes.
the left side, this is called LHL, left hand limit.
Yes.
Okay. So we can say if x is tending to 1, then RHL we can say is 1 plus h, where h is a very small quantity, 0.00001, right?
Yes.
And LHL will be 1 minus h. Clear?
Yes, sir.
All right. So if limit exists, all right, if this statement is true, if limit exists, that means this value exists, then what we say, LHL must be equals to RHL. All right. What this means, I'll explain, but remember this: if limit exists, then RHL must be equals to LHL. What does this mean? If I write limit extending to 0 f of x, then I am saying what is the value of f of x when x is tending to 0. All right, x is not equal to 0, but x is tending to 0. So what do I mean by this? Suppose there is a function and there is a gap in the function like this at a point 2. So if there is a gap, that means function is not non-existence there, right? Function is not there at x equals to 2. So I cannot put the value of x as 2, right?
Yeah.
If you put x equals to 2 here, this is 4 minus 4 is 0. Upon 2 minus 2 is 0. So we know 0 upon 0 is not defined, right? We don't know what this value is.
Yes. Yes.
So then we try to use limits. That where a function is non-existence, can we try to estimate what would be the value of limit in there? This is called limiting value. All right, we were not trying to find the exact value, but limiting value.
Yes.
All right.
Yes, sir.
Okay. So when do we try to find limiting value? When the function is not defined. Very simple. All right.
Yeah.
So there are few methods of evaluating limits. Direct substitution is first one. All right, write down a question. All right, always remember, direct substitution is the first method to evaluate limits. What we do here,
Yeah.
we try to put the value of x as 1 directly in the function, right? This is the function.
Yeah.
So just put x
Yeah.
equals to 1. All right. So if you put x
12.
equals to 1, this is 12. So this is the answer because 12 is not defined. So this 12 will be the answer. All right.
Yes. Yes.
Please find the values.
Zero.
0. Third one.
And this is 2. No, this will be 1.
Are you sure?
Yes.
Under root 1 plus under root 1 upon 1. So the answer is 2, right?
Yeah.
Right, so don't rush your answers. All right, silly errors will take a lot of marks. Next is factorization. Direct substitution is clear, right? Always try to put the value of limiting value in the function. You will
Yeah.
see if you are getting the answer or not. Factorization. Right, write down a question on this. Limit extending to 2, x square minus 5x plus 6 upon x square minus 4. Again, whenever trying to evaluate the value of a limit, always use direct substitution first. All right, so let's put x equals to 2 here. So what we will get? 4 minus 10 plus 6 upon 0. So 10 minus 10 is 0, 0 upon 0. This is not defined. So we can see direct substitution fails here, right?
Yes.
So the second method is factorization. So what we try to do? Factorize the numerator, factorize the denominator.
Yeah.
So please factorize, tell me what you get.
X square minus 3x minus 2x plus 6.
Right. And after that,
And x minus 2, x minus 2, x plus 2.
so please factorize this again. You have to solve it completely.
X minus 2, x plus 3.
Absolutely. We can see this is cancelled. Now again, we have to put direct substitution. So if you put x equals to 2 here, so 2 plus 3 is 5, 2 plus 2 is 4. So the answer is 5 upon 4. All right.
Yes.
Clear?
Yes.
I have one question. All right, I'll give you a few minutes. Done, Firaz?
We're supposed to rationalize the denominator, right?
You just have to factorize. You can use this identity a cube minus b cube here in the numerator. Do you know this identity?
Yes.
So please use this a minus b a square plus ab plus b square, right? You can use this identity in the numerator, and you can see the only way to factorize a cube minus b cube is using this identity. All right, this is the factorized form.
Yeah.
So use this, you'll get the answer very easily.
The answer is 3.
Absolutely correct. Try to solve this one. How to do this one? Do you know how to factorize cubic equation?
You will
Didn't
take
tell
an
me.
x outside.
Right. This is x tending to 2. All right. So because if you put 2, this is becoming 0. So we can say x minus 2 is a factor. Then you have to do long division, right?
Yeah. Right.
Then you
G
can
of x.
factorize and right. And in the denominator, you can take x square as t. So this is t to the power 2 minus 8t plus 16.
Yeah.
Right. Then you can factorize this, then factorize it again. All right, replace t with x. After factorizing, you'll get the answer. All right.
Yeah.
Please do it. I'll give you a few minutes.
You can divide both, right? The same way.
Yes, you can divide. Absolutely. But this is like easier method because you will use middle term splitting and you will get the answer very whichever way you want. All right. Because if you
Okay.
divide by x minus 2, then you will get a cubic equation, right? Then again you have to divide by something to get a quadratic, right?
Yeah.
So whenever you see to the power 4 and you have to factorize, always do this. Assume x square is t, then use middle term splitting, or you can see this is t square minus 2 into 4 into t plus 4 square. So a minus b whole square, right?
Yeah.
So this is the easier way. All right.
Yes.
So please solve it. Done, Firaz? Solved it?
No, sir. I have another equation.
All right, see. If we do long division in this is x square. So x cube minus 2.
X square
2x.
minus x minus 2. You get.
Right. If this is minus x square, right? Because minus 3x square plus 2x square is minus x square.
Yeah. No, I meant the
Okay,
quotient.
final answer. Quotient.
Yeah.
All right. Right. Absolutely correct. So we can write this as x minus 2, x square minus x minus 2. And this is, I already told you, this is t minus
4
4.
whole square.
So x square minus 4 whole square we can write like this. All right. So x square minus 4 we can again write x minus 2 into x plus 2.
Yeah.
And let's see if we can factorize this also, multiplying minus 2, addition minus x. So we can see x square minus 2x plus x minus 2, right?
Yeah.
So limit extending to 2, x minus 2. This is taking x common, x minus 2 plus 1 common, x minus 2. So x minus 2 whole square, x plus 2 whole square. So I can see x minus 2 is getting cancelled here, right? Square.
Yeah.
So in the numerator we will get x plus 1. In the denominator we have x plus 2 whole square. So if you put x equals to 2, 3 upon 16 is the answer. All right.
Yeah. Yes.
So factorization is clear.
Yes.
Next type is rationalization. All right. Rationalization you have done in class 9th, I guess. If you have root 2 upon root 2 plus root 3, what we tend to do? We tend to multiply with this, right? Whatever there is in the numerator or denominator, change the sign and multiply same thing in the numerator and denominator, right? So this becomes this, but the denominator becomes a square minus b square,
Yeah.
right? This is called rationalization. So please try to solve one question. And remember, here also always try to put direct substitution first, then try to use any method. All right, you can see here in the numerator we have two terms, so we have to rationalize the numerator. All right, got it, Firaz?
Yeah.
All right, please tell me the answer.
Should be 0, right?
Let's say if you multiply or rationalize this, root 2 plus x plus root 2 all divided by root 2 plus x plus root 2, right? Yes or no? So this will be root 2 plus x whole square minus root 2 square. Let's keep it like this. So this will be 2 plus x minus 2 whole divided by x into this term. So you can see this x and x is getting cancelled. So 1 upon 2 plus x upon root 2. So if you put x equals to 0 here, so we get 1 upon 2 root 2. This will be the answer. Is it clear?
Yeah.
All right, next question. Right, so they might give you in the denominator or numerator. We do not care about that. Just multiply changing the sign. You get the answer. Write down limit x tending to 0, x upon under root a plus x minus under root a minus x. All right. Done, Firaz? Have you solved it? Firaz, have you solved it?
No, sir.
All right, how to solve this? Can you tell me the first step?
Times root 1 plus x
This is a plus x, right?
plus, yeah, a plus x plus a minus x.
A minus x. Absolutely
Then
correct.
divide by the same thing.
Absolutely. Now,
So it'll be x times root a plus x plus root a minus x by root a plus x whole square minus root a minus x also.
all right. So the next step,
And then numerator as it is,
all right.
denominator will become root a plus x. Sorry,
No,
a plus x minus
a plus
a
x,
minus x.
right? Did you use this brackets here?
Yeah,
All right. So limit extending to 0. This is p upon a plus x minus a plus x, right?
yeah.
So this a
So
minus a is
p by
cancelled.
2x.
So p by 2x. Now p, here we have x also. So
So
that will be
xp.
cancelled, right? So under root a plus x plus under root a minus x all divided by 2. Now you can put x equals to 0. So under root a plus under root a, 2 under root a, 2 and 2 is cancelled, and the answer is under root a.
Under root.
Got it? So you solved it, right?
Yeah.
All right. Next question. Limit extending to 0. Under root a square plus x square minus under root a square minus x square whole divided by x square. All right.
1 by root a square, or 1 by a, yes.
All right, this is clear, right?
Yeah.
So rationalization is also over. Now we have some standard limit formulas. Note it down. All right, so in most of the cases, you are going to use the standard formulas. If you have limit extending to a, x to the power n, a to the power n upon x minus a, this is n a to the power n minus 1. Very important part. All right, suppose we have limit x cube minus 3 cube whole divided by x minus 3. All right, limit extending to 3. So according to the formula, here the value of n is 3 and a is also 3, right?
So 9, 3 minus 1.
3 into 3 to the power 3 minus 1, right? Not 9. N into a to the power n minus 1.
Yeah.
So this is 3 into 9, which is 27. All right.
Yeah.
Write down a question. Limit x to the power 10 minus 1024 upon x minus 2 extending to 2. I'll give you a few minutes.
Phi 12.
All right, how did you solve this?
2 to the power 10 minus 2 to the power 9.
So power is n. So value of n is 10 into 2 to the power n minus 1, 2 to the power 9, right?
Yeah.
So you can say this is 5120, right?
Yeah.
All right. Next question. Remember, there is a property of limit that if denominator and numerator is there, you can divide, right? You can like limit x upon y, you can write limit x upon limit y. All right. Or if you don't want to do this, you can like solve this one differently, this was differently. What do I mean by that? Limit x tending to 2, what you can do here is this is 2 to the power 10, right?
Yeah.
To get this formula, we need a x minus 2 here, right?
Yeah. Yeah.
So what I do is I multiply x minus 2 and divide by x minus 2 just to get this formula, because once I got this formula, I can use that, right?
Yeah.
In the denominator also, this is x to the power 5 minus this is 32, sorry. So this is 2 to the power 5. So again, to use this formula, I have to get it x minus 2 here. So what I do, I divide and multiply by x minus 2. So this thing is cancelled. Got it?
Yeah.
So I can use this formula in the numerator and in the denominator, and
You
I'll get the
can
answer.
again cut the x minus 2's, right? In the
No.
denominator.
If you again cut this cancel out, then you cannot use this formula, right? We'll get to the question again,
Oh, yeah, correct.
right? We multiplied and
Yeah.
divided because we want to use the formula. So use this
Yeah,
formula
so
in the
it's
numerator and in the
5120
denominator,
by
right? See, you can write like this: 10 2 to the power 9 upon this is 5 2 to the power 4. So 2 into 2 to the power 5, this is 2 to the power 6. Alright, 2 to the power 6 is 64. Got it?
yeah.
Alright, please note it down this method. Done, Firaz?
Yes, sir.
All right. Few more formulas. Limit theta tending to 0, sine theta is 0. You can use this standard limits everywhere. Limit theta tending to 0, cos theta is 1. Limit theta tending to 0, sine theta by theta. This is equals to limit theta tending to 0, tan theta by theta, and this is equals to 1. Very important one, this third one. And remember, when I write theta, this means any angle which is in sine, right? You can have 5x, 10x, 8x. If you have sine 5x and it is divided by 5x, you have limit extending to 0. So if 5x is theta, then I can say theta is tending to 0, sine theta upon theta we have. So this will directly result into 1. All right.
Yes.
Please note it down. All right, try to solve this question. If you have noted this down, sine 3x upon x. Done, Firaz? See, to use this formula, we can do the same thing. We have sine 3x. So to use this formula, we want to have 3x in the denominator. But what we have is x. So what we can do, multiply by 3 in the denominator and in the numerator. This thing is clear?
Yes, sir.
So what the final answer is? 3, right? This becomes 1. The answer to this limit is 3. All right. Is it clear or not?
Yes, sir.
Next question. Limit extending to 0. Sine 5x upon 2x. Please get the answer. Done, Firaz? Yes or no?
Yes, sir.
So what is the answer?
5x. Sine 5x.
No. See, To use that formula, we need to have 5x in the denominator.
Yeah.
Right? Sine theta upon theta. So what I do, I divide and multiply by 5x. What is remaining? 2x is remaining. So this x and
Yeah.
x is cancelled. So this will become 1. So the answer will be 5 by 2. All right.
Yeah. Yes.
Now is it clear?
Yes.
All right. So few more formulas today. Let's give it to you. Limit extending to 0. A to the power x minus 1 upon x is log a. Limit extending to 0. E to the power x minus 1 upon x is 1. Limit extending to 0. Log 1 plus x upon x is 1. All right, note it down. And one question for homework also. Limit extending to 0. Sine of ax upon sine of bx. All right. In the next two classes, we are going to complete this chapter.
So from next chapter, can we like go for the exercises like straight,
Okay,
like
you
not
don't
too
need to
much
like
in depth?
in depth. Like you have any ideas like how to do application of derivatives?
Yes.
All right, then from the next chapter
So
we are
like
going to
I've
discuss.
already learned those chapters, so I just need
Okay.
like.
Okay, we are going to do questions only. All right, no need to do the theory.
Yeah.
All right. From the next chapter we'll do that. So this is done.
Yes.
All right, then this is all for today's class. Have you completed the assignments?
So which one?
The last assignment you must have got is parametric form, differentiation of parametric form, and exponential logarithmic form. Are you receiving assignments?
Yes, sir. There is one due for today. Differentiation.
Yes, please complete that by the next class. All right.
Yeah. Okay.
Okay, then take care, Firaz.